Hello everyone, my name is Rohit, TESCON Bangalore. TESCON is a leading distributor of highly advanced research equipment manufactured mainly in the US and Europe. TESCON Analysis exclusively deals with high-speed cameras, motion analysis software, and other test equipment for university, automotive, and defense research applications. Today we have with us two OEMs together, Photron, who is the leader in high-speed imaging segment, and Image Systems, who are expert in motion analysis. So Tescon, as a sales partner of Photron and Image Systems, has been supporting Photron and Image Systems products for the Indian research community since over 2 decades now. We have Mr. Andreas Mangold from Photron Europe Limited, who would brief about Photron high-speed cameras, and Ms. Yujiao Yuan from Image Systems Sweden, who would take us through the DIC techniques in different applications using the TEMA DIC tool. Thank you once again for joining us, and I welcome Andreas and Yujiao. If you have any questions during the course of webinar, please drop them on the chat box. We will have a short Q&A session towards the end of the webinar. Over to you, Andy and Ujia. You could start now.
Good. Thank you very much, Rohit, for this short introduction. Just one or two words from my side. So it's really a pleasure to work together with TESCON and also with Image Systems. And the relationship is quite a good one, and we are really happy to be in that situation that we can give you this presentation today. At first, I will give you a short overview about our company, about Photron itself. Then I will go a little bit into the hardware of a high-speed camera, or why do we need high-speed cameras, a little bit about the history, and then I will go straight to application. But I will just give you 10 or 15 minutes presentation, and then we will go straight over to Image System, to the really interesting part of DIC, but you will hear later much more. So I will share my screen. Great, now you can see my presentation, and I will go straight into the company Photron itself. So Photron is a Japanese company. We are based in Tokyo, in the middle of Tokyo, and we are, I would say, quite old. So we are founded in 1968, and we are around about 300 people around the globe. Our main core is high-speed camera technology, but we also have some sister companies who are more into the CAD or CAD software. But most of our companies are related to image and image processing. We have, next slide, here. We are a kind of global player worldwide. We've got some subsidiaries. As you can see here, we have got in the US a subsidiary, but also in Shanghai and in Vietnam. And our European headquarters is based between London and Oxford, and we've got a German subsidiary where I'm already currently sitting close to Stuttgart. Maybe you have been already to a trade show in Stuttgart, so we are close to the airport. Our partner in India, as you're already aware, is TESCON, who is covering the complete area of India, and it's really for us a great situation to work with TESCON. Here you've got an overview about our customers and the markets where we are in. So we are really deep in the automotive industry and also in aerospace and defense, which are also really big industries in India. And you can see all the logos from the big partners we've got there. So now I would like to go a little bit into the technology and our products. But the first question we have to answer, why do we need high-speed cameras? And one of the answer is our Earth, our world itself, because our life, our world is full of phenomena and processes who are too fast for our eyes. So if we go a little bit into in the eyes itself, so an eye or a human is able to capture around about 24, 25 images per second. But when you think about a bullet or a car, which is too fast for our eyes, and that's the reason why we do need high-speed cameras. Here are, I would like to explain you a little bit why we need sometimes so high frame rates, because when you think about a normal video camera, which goes to 25 or maybe to 50 frames per second. But then when we compare, for example, here a human movement where you see someone is walking, and just if he is walking or she is walking 1 meter distance, and you would like to have 2 pictures of these movement, you probably need already 2 frames per second. And if you would like to analyze the movement of a sport, of a footballer or rugby player or whatever, so you need much more frames per second. And that's already common. Even my iPhone is able to capture 250 frames per second. So for a human movement, that's quite good. But then when we go into something like a bullet fired by a normal gun, it's completely different, because when we say a human is walking a meter within a second, a bullet will pass a meter within 3 milliseconds. And to be honest, that's a really slow bullet. There exists much faster. But if we go further with that test or with that idea, if we would like to see the bullet within a meter 2 times, then we should have a camera which is able to go to 680 frames. But you can imagine with 2 images, there's not much to analysis. Therefore, if we go further, so if we need 250 frames to analysis, maybe the rotation or the behavior of the bullet, you already need 85,000 frames per second, and that's quite a lot. Here there are some other examples of a slow walking man, a running man, a car which just drives 45 kilometers, or a car with 100 kilometers, and here a bullet with 340 meters per second. And to be honest, that's not the fastest action we are able to capture. This slide should give you a little bit of an idea how a high-speed camera is working. So the core of a high-speed camera is here in the front, the sensor. So this camera is figured into the direction of the dummy you see here. So the sensor, it's probably the main of or the core of a high-speed camera, and we are manufacturing the sensor by ourselves, so it's self-designed by us. So we don't manufacture it, but we design it, and we have partners who are manufacturing the sensor for us. When the sensor has captured the image, it goes straight to a converter, which converts the analog signals into digital signals, and then we put it into a memory, and probably there's a powerful CPU inside and some more electronics. Here, as I told you already, the sensor is really the core of our business, and it's self-made. And what is really important for a high-speed camera is you need high light sensitivity and a really good image quality. And what we need as well, because we do everything our own, we need really low noise circuit boards and really robust housing, because these cameras are made to be in really harsh environment. If you can imagine, for example, this camera is built to be built into a car, and when we do crash tests, so a car is hitting a wall or other car, all these shocks has to be observed by these cameras. So it has to be really, really ruggedized. Here you can see a short history of the Photron products, and I've just grabbed some of them. We've got much more product over the last years, or 30 years, I have to say. So we have started in 1992 with the first, or one of the first digital high-speed cameras, which is the Actor Pro. And then you can see it has increased over the years, the frame rate and the resolution. And also the features has become much more. So when you think about the first one, we have been really happy just to capture 4,500 frames. But now we're talking about image analysis, where you can do an image trigger. So you trigger by movement in the image, or video output, and much more. So the next image you can see, it's our current product range. We have quite a wide range of cameras, because there are also a wide range of application where we can use these cameras. On the left side, you see that's our latest model. That's the Fastcam Nova. And here we have at least 5 different types of performance. And we have our flagship, the SA-Z. But then we have also some cameras, as already told you, the Fastcam MH6. That's one special made for crash test. And here, that's one of our most sold camera, the Mini series, with different performance. Now that was I would say, the boring bit. Now let's go straight to our application, and to give you an idea where we use all our cameras. And here I've grabbed out some really impressive examples. And so where's my mouse? Here. One of the most impressive example is the Eagle Eye. Eagle Oil, because it's so impressive how this bird is landing, and it's one of the prettiest high-speed imagings I've ever seen. Oh, one's back. Here, that's ballistic. So how a bullet is leaving the muzzle. A really important application is welding. So here, probably you can't, so it's not visible, but you see the result. That's a laser welding process. So a laser is, in this case, cutting a piece of metal. Then we also have, for sure, the whole crash test. So here's a full-scale test where a car is driving, I guess it was around about 40 kilometers an hour against the wall. It was a Euro NCAP test. Another big area is engine research. So we do a lot of burning process, so injection, also the fluid dynamics of the spray, and the flames, so the combustion process itself. So here we have what we called cavitation. So we see that's the plate, or that's the how it's called, the wheel of a ship, which when it's turning in the water, it's creating these bubbles. Another application is microscopy. So it's really, you're seeing here less than a millimeter of a subject. So and small bubbles are going into another liquid. So there's a liquid flow, and some, I guess it was oil bubbles are created just by press it into the next liquid. Here, there's also some liquid research or fluid research, fluid dynamics. So here are the comparison between different liquids and how they behave when they hit a surface. Here's another application which probably is maybe interesting for you. It's tensile test, and tensile test, it's really perfect for DIC, for digital image correlation, and probably you will hear later more about that one. And here's some examples about tensile tests. That was a really stiff material. That's a tensile test as well. Here, that's aluminium. See how it's bended, and in the end it cracks. Here's another tensile test, but here's the opposite. Here's a kind of drop test, or when it's been pushed. Okay. So here are some nice images from our setups, so from some setups, how customers are using our cameras. And as you can see, we are not only inside or in a laboratory, in a lab, we also doing stuff outside. Many kinds of application are also been outside. Here's some more. For example, here that's I guess it was in a steel manufacturer, and it was really hot close to the camera. But really, as long as the lens doesn't melt, everything is fine. Here you see an engine, but that's just a model. But that's typical how the cameras are installed onto an engine. And as you can see as well, we have also multiple camera setups where many cameras are run in the same time. And the last one, it's one of my favorite videos, and I would like to show you that one, because that's an overview about many applications in one go. I'm sure you're not able to catch them all, but I think it's really impressive. So you see all kinds of tests we have done with our cameras. So I probably will give you 1 or 2 minutes to have a look. So that's from my side. Thank you very much.
So Rocket, may I continue, or?
Yes, yes, you could.
Okay. So thank you everyone. My name is Yujiao Yuan. Yuan is easier to pronounce, so just call me Yuan. And I'm from Image Systems. I'm really glad to holding this webinar together with TESCON and Fortran. And really, Andres gave us a very impressive presentation with amazing videos and applications. And now I will show some applications and also our products through my presentation. Now, please, 1 minute, please. I will show my presentation here. Please let me know if you can see it.
Yes, we can see.
Yes.
Okay. So I'll start now. First one, I would like to give a brief introduction about our company. Image Systems was founded in 1988 in Linköping, Sweden. It is a publicly traded company listed on the Swedish Stock Exchange. Image Systems focuses on high-end measurement systems using image processing as a base for more than 30 years with a long history. Our company has two business units for now. One is REMA-SOCO and the other one is motion analysis, which I work for. REMA-SOCO focuses automation, scanning, and optimization of embarked logs to finish boards for the sawmill industry. And motion analysis provides powerful and accurate measurement solutions through image post-processing analysis. Mainly, we have two products like TEMA and TrackEye. TEMA is the product that our topic today mostly based on. And TrackEye is a flexible and programmable software. These two softwares, when motion comes, they will help. So if you are interested in some further information, please just contact Rohit or me, then we will have some further discussion or communication on this. Image Systems is a worldwide company, and we have 6 offices all around the world. As I mentioned, the headquarters is located in Linköping, Sweden. We also have offices in Israel, France, China, and also USA. All these offices will support all our distributors, more than 60 distributors all around the world, to cover all the requirements or the demand from customers. Actually, TEMA is a well-used software. So we have customers in all kinds of areas like defense, aerospace, automotive, institutes, universities, and also automation factory, manufacturing, and electronics, and so on. So our customer footprints also spread in all areas. So actually, what TEMA is, what can it do? We can say that TEMA is the first or the #1 world reference software in tracking. We provide about more than 10 tracking algorithms with something like a current tracker, correlation, intersection, outline, and so on. No matter if you could put markers on the object or you can only use the features from the object, we can just following and tracking the movements and give you the analysis results. Also, we use smart incremental correlation so that we get very robust algorithms. TEMA supports GPU acceleration, so we can have the image processing very rapidly and get the results rapidly. Nowadays, we care more and more about the accuracy of our image processing. So in this case, TEMA provides several correction or calibration methods or tools to make the analysis results more accurate, like angled motion plane correction, which could correct the error introduced by the angle between the camera plane, sensor plane, and the motion plane or the target moving plane. Also, we can give some correction about the camera vibration to eliminate the vibration and the errors. We also have lens calibration, as we can see the upper right picture. That is the pattern of our lens calibration board. We have 2 kinds of that to make the distortion, to correct the distortion of lens. Also, we have some 3D survey tools like 3D Wand, static 3D to get accurate 3D coordinate information. Not only 2D analysis, TEMA can also do the 3D 6DoF onboard 6D analysis for many kinds of different applications. And also depends on different requirements. We could do the camera orientation flexible with like static orientation or relative orientation. It depends on the applications. Also, TEMA is the first one who combine 3D models and the motion analysis together. That means we can import some 3D models like the pictures in the bottom. We can scan some modeling and then get the 3D data and we import them into TEMA software. Then we can do the analysis with 3D or 6D to get more accurate motion analysis about the targets. Besides those, TEMA also supports cameras raw file formats, like high-speed cameras, also some streaming cameras. In this case, it is very convenient for the customers to use this software because you don't need to transfer the raw file to some image or video formats. You just use the raw file. You will get a better result. And optional, we provide camera control to control the high-speed cameras or streaming cameras by software. So one software do a lot of things. Yeah. Maybe you have some aware of TEMA software, and in the past years we have TEMA Motion, TEMA Automotive, TEMA Defense as the TEMA structure. And in the year 2020, we have done some modification. Now we have TEMA Classic and TEMA Pro as the new structures. They are more powerful and more concise. TEMA Classic and TEMA Pro, they both the basic engines to do the motion analysis with multiple tracking algorithms and also multiple diagrams or tables to show or to present the results. Besides that, TEMA Classic, it has 2.5D correction, stick figure, dynamic coordinate system, mouse tracker, include and exclude area, and so on. So much features to be provided within Classic without more money charged. And TEMA Pro is based on TEMA Classic. That means TEMA Pro contains all the features TEMA Classic has. And then it has also auto lens calibration, outline tracker, viewer, DSC, and so on. So much features there. So it can also do like DSC, the main topic we have today, and also some motion analysis together. So it's very convenient. Now let's go into our main topic today for the DSC. What is DISC? I guess most of us has the concept of this algorithm. It's defined by how a surface or object is deformed, not just moved. And as we show in the right hand, there is the string or string draft to make you have a better concept of DISC or the string. And it is a surface deformation and strain analysis in full field. That means like other common methods for measuring strain, we have strain gauge or extensometer, but those are contact technique, and we just have information from one point or one specific area. But now we have DISC with software and camera images, so we have the full field deformation and strain analysis. We have more information, and this is non-contact technique, which makes the experiment or the test more easier to set up. So this is a very high efficient method to do the string measurement. Besides, one important factor of the DIC analysis is SPECKLE. We requires random pattern of multiple contrasted strings on the surface. Like we can see on the right hand, there are 3 different type of speckles. So we will do the millions of measurements over sample surface for DIC. And critical points can be easily identified. That's what we should do to the speckle. How could we create a good speckle? Here are some tips, like we need good contrast and sharp edges for the speckles. And it's better to have points or details with the size of 3 times 3 pixels to let the software recognize better. Like the upper image, we can see that that pattern is made by paint, like matte sprays in drops. And also we could have such speckles with stamps, which generated by software or some hardware stamps, but the pattern could be generated by software. And also we can use the natural texture of the object to be good contrast in the images. And regarding the stamp, TEMA DIC could provide extra software for this speckle generating, and we can give a ready speckle pattern for printing, and we just manufacture our own stamps for easy speckling. So in this case, it will optimal tracking accuracy and guarantees good contrast and varied homogeneous sized speckle pattern. We know DIC is a method, and now many vendors has this method to do this. What TEMA DIC is? What is the features of TEMA DIC? First one, it has 0.01 pixel accuracy, and we could provide complete turnkey systems. It's quick and easy setup, so it's very convenient to use. Otherwise, TEMA is a motion analysis software, so TEMA Pro also has a lot of other tracking algorithms. They could assist, and there is no need to some specific markers in some cases. Besides, we know sometimes when we do some test or measurement about the specimen, we also have some dynamic situation there. So TEMA can not only handle the static loading, but also dynamic loading. And also we can handle different motion planes, like I mentioned before, like the 2.5D with camera angles there. About the string range, it is much better than the traditional one, like string gauge, because it uses images, so it can support 0.005% to 2000%. TEMA software, TEMA DIC supports GPU acceleration, which makes the processing very fast. And we can show the results like surface deformation and strain, as well as the 3D or 2D movement, velocity, acceleration, presentation, and so on. So we have one software for not only motion analysis and 2D DIC for free. So, and at last one, we can provide the viewer and template. That means if we have viewer, sometimes when we use software, we need a license, like a dongle license or standalone license. But if we have this viewer, we can show the tests or the analysis results in a computer without license installed, just see all the results there. And we provide a template, which means if you do some similar tests, the first time you prepare for the whole procedure of the tests, and then you create a template. After that, you will have another or more tests, or you just need to import the videos or the images sequences, and then we can generate the results as the template. You don't need to set up all the procedures again and again. We just have this very convenient tool. TEMA DSC also provides inspection lines and virtual extensometers, local points of interest as tools to demonstration or to present the analysis results. Like image diagram, we can show the displacement or strain with color maps. In advanced diagram, we can have the inspection line versus pixels relationship. And also we can have XT diagram to show the virtual extensometer versus time, the behavior. Yeah, after we show the concept of DSC and what TEMA DSC can do, now let's go into the tracker setting, because this is very important when we do the experiment or do the test. There are two important concepts here. One is subset size. That means the template size. It defines how large a tracked set of pixels will be. Like we show on the screen, there is a frame, a red frame. Those pixels inside the template size will be computed. And we will have multiple or plenty of such subsets so that we can do the computation. How much or how can we cite this subset size? Actually, we need another concept about step size that defines the center-to-center distance between subsets. That means the software will use those step size to cover all the specimen or the surface of the object. How do we define these sizes? We have some tips here, like subset size. We need to be proper, because if you use larger subset size, it is easier to track, but it is more computational time. So in this case, we will use 15 to 25 pixels to as a typical size to make the computational time proper and also get a good result. And step size, if we have big step, it might miss strain gradients or amplitude of a peak. If we have small steps, there are risks picking up on noise errors. So typically we will use 10 to 20 pixels in this way. Another parameter for DSC tracker setting is about the tracker tolerance. It determines how good of a match of point should have to still be kept. Best to keep it at default value about 10 to 20%, but it also depends on the image quality. So actually our engineers will give you some typical suggestion on when doing the first or doing the training about the experiment. After that, you will have some experience and you will get a very accurate and very easy to set up. We also provide offline and online accuracy reports so that you can check if you have a good image quality and if you have a proper parameters setting. As I mentioned, we have some tools for the calibration and correction. Now we will have lens calibration here to improve the results. First one, we know if we use some lens with the very small lens focal length, it will have some distortion here, and it will introduce this error. In this case, we will use our calibration board as a tool, then do the calibration. We have two different patterns. The second one, we can do auto calibration. So in this case, we can get residuals for each frame and also calculated focal length, impacts of lens distortion, coefficient for radial distortion correction, and so on. With these parameters exported and imported in our tests, we can get corrected results and with the images. Besides, we will have the 2.5D correction. That means when the camera sensor plane is not perpendicular to the motion plane, then the angle, even small angles like 3 to 6 degree, can cause errors of up to 10% in stream. So this really matters in our tests. In this case, we will have 2.5D calibration to eliminate such errors. Yeah, about the accuracy, here is a setup of our products and the systems. In this case, actually, the customer would like to compare the accuracy with other vendors, and we get a better accuracy here, and we get the vendor, the tender. And as I said before, we have different trackers or algorithms for motion analysis. In this case, for doing DIC, we can also use other trackers like outline tracker and other trackers to assist. And we can not only get the DIC analysis results, but also the outline and or the shape or the movements of the specimen. TEMA DIC is well used in different applications like ballisticists, defense, simulations, automotive, structural, and so on. So now I will show some videos of the applications. I think the most common one is tensile machine, as also Andres showed us some setup of that. So in this case, I will show the video about this tensile machine. In here, we can see we have the color map of the strain or displacement, and also we can have the inspection virtual extensor here as diagrams. And also this could be export and also like data export. Also, we can import some data about like mass or some other data from outside or the third party, and then we can have the diagrams together with those data and our string. The second one is about the deformation with in-plane load or forces. We can show some vectors here and also show the color maps to know the deformation and the strain. Also the inspection lines here in different places and show them in the same diagrams. Also, it is used for some concrete analysis with some load or forces. So what I have shown is DIC concept and also the algorithms, the analysis results. Now, how could we do a DIC analysis with TEMA software and also the system? Here is the workflow. First one, we need to set up the cameras, illumination, lenses, and so on. And then we could do the lens calibration, 2.5D calibration, and also stereo, also camera orientation or for the stereo DIC analysis. And we have some tools like 3D wand and 3D scanners to assist. And after that, we will use algorithms like quadrant algorithm trackers or DIC trackers to set up the trackers and then tracking the specimen and then just tracking do the analysis and just put all the results in different diagrams or tables to show all the analysis results and just export all of them. Not only images, movies, or also ASCII file or Excel file with data, and we can use viewers to show the test on some computers without license installed. Here is the video about how TEMA DIC work. First one is just import the images and set up the frequency or the camera parameters. And then we have the images with speckles and add the tracker which we can set up for DIC. Here is a setup window, and we use a map for the area we are interested in, and then just set up the subset size and step size and also tolerance, tracker tolerance, something like this. And then just press tracking. We will have all the data or the image calculated. Now, actually, we already have all the results, but we need to present them or to show them on the diagrams or the tables. Now we can set up inspection lines or virtual extensor meter or points of interest. Then we can have the results in the diagrams. Yes, now we have add two virtual extensor meters, and then we add two diagrams to show them. Also, we can use image diagram to show the color maps of the displacement or the strain, the deformation. Also, you can just choose if you would like to show the vectors or not. Now we have all the results presented. Okay, now we can export. Yeah, first to have those data in a table time so that we have the value. Yeah, we can choose the components which we are interested in for the strain. And then export. And the right hand, this video shows what a template is and how it works. And as we can see, we just use the template and import a video or an image sequence inside the software. Then we get all kinds of analysis results as the left side. So this is very convenient when we do them fatigue test or other things. Yeah, TEMA not only can do 2D DIC, but also stereo DIC. Since it is a software which can do also motion analysis, so it is very convenient to create a stereo DIC. Just uses advanced algorithm to calculate the XYZ coordinates of thousands of points to acquire full field deformation, strain data, and shape of the analyzed surface. It uses triangulation on two 2D trackers to acquire 3D data, and it will automatically match the second camera to the first one. The best stereo DSC angle we suggest to be 15 to 20 degrees. So in this case, how do we set up the stereo DSC? Actually, we just need to do the camera orientation and then set up the tracker just like in 2D DSC for the first camera. And in the second camera view, we place a slave DSC tracker. Then the camera will just match them and tracking them and get the result. That's all. The points have to be visible in both the master and slave tracker for 3D data to be calculated, that's for sure. And it also supports multiple slave tracker views. But all points have to be visible in the master tracker. And also it has some requirement for the computer performance. Stereo DSC presentation, now we can see in the 3D diagram, we can see the strain displacement shown here. We can also see the displaced vectors, also the camera positions and orientations. It is very visualized, and we can see the deformation very clearly. Besides, we can also show the some like 3D inspection lines and extensometers and point of interest in the 3D diagram, and also all the classical visualization tools in 2D, as we can see here. Now I can show you some application videos for 3D stereo DIC. This one is a compression. With the specimen is compressed with some loads, and then we can see in the 3D diagram about the deformation, and also with the color maps to see the large or the small deformation places. And we can have like virtual extensometer or inspection lines, and also the vectors about the deformed direction. Besides, we can also see the movement of the deformation procedure. Yeah, this is the inspection line here, and we can see the diagrams. Yeah, for the second video, we can we have a blast application here. It is dynamic stereo deformation of metallic plate under the action of a blast shockwave recorded by high-speed cameras. So this 3D displacement, as well as the main or minor components of the string, can be displayed in the 3D diagrams with color maps. And also, we can get a full understanding of the blast behavior. Then we can, like this place, we can place a point of interest on the surface, allows the end user or the customer to measure the displacement maximum locally, as well as the frequency here of the plate vibrating with the shock wave. So it combines both DSC and also the motion analysis. Here is about the shock, and also something like skin deformation analysis. Because under the influence of body movements, or shocks or impacts, the skin or the fabric can deform in an elastic way. So in this case, we can show this all of this deformation and vectors and analysis results to help for the future design of sporting equipment or to help to our foot or some identity or some body which could lead to back pain. So we can do something to help to do better equipments to reduce the pain or healthy for our foot or our body. The last one here is actually is a drop test for the like phone or tablet. So we can see that we can do the movement analysis of all these markers or the places that we are interested in for motion analysis. And also we can have all the data in the diagrams or the motion analysis, stereo or 2D. And then we can also have the deformation or DIC analysis for the drop test on the surface. So in this case, we also combine the movement analysis and also the DIC analysis together. So I have shown some application videos, but just a few of them. We also have plenty of applications in all kinds of areas. So just when motion counts, when DIC or string analysis counts, just the TEMA Pro. And we provide the flexible solution or turnkey solution for DIC systems. First one is the DIC 2D Elite, which is fully flexible solution that you can choose cameras with different parameters as the application requests. And this DIC 2D Elite system supports any or many kinds of high-speed cameras or brands. And also it has LED lights, and you can it can be orientated in different angles. And also we have laser alignment tools to make the accuracy, to make the alignment more accurate. It is also compatible with DAQ systems to have more data or the system aligned with other third-party equipments. Also, we have embedded system for stereo DIC, and it is fixed configuration is much more easier to set up. And also we could provide the cameras, the lenses, the illumination, and also the calibration together. Is a turnkey and off the shelf. The other one is the stereo system with high-speed cameras. As we can see in the right hand, the picture is for photon cameras. Actually, it is compatible with all major high-speed camera brands, especially for all photon models. And we provide high-powered LED with continuous homogeneous light, which is very important in high-speed DIC. And all the system will delivered with optics and calibration board and all other necessary accessories and equipment. Also, we will provide the speckling tools. So all the necessary parts could be provided within the system. So it is very convenient and high efficiency. Now, please, those are the introduction about TEMA DIC and the basic information of TEMA. Now, please allow me to show some 2 videos for you about what TEMA can do of like defense area, aerospace area, and also automotive area. So this one, the first one is for the defense area. Yeah, we can, for the bolt handle blowback visualization, and also the analysis, the speed analysis. Also, we will have all these values here versus time, like speed, acceleration, angle, and also displacement. This is actually a 60 of analysis of varying result. We can see here, this is 60 analysis results in a 3D diagram. We can see the like the rotation or the status of this, and also the position, the 3D position. These are the diagrams for the curves about the 3D and the attitudes. And also this is outline tracker. We can see the projectile trajectory and also the cultivation formation. Speed. The movement, the area or circumference of the outline tracker. Oh, sorry, last one. And also for automotive industry, we have some applications. Like we can do the spring analysis, and we can do the vibration elimination. And also comparison of the cycles, frequency analysis. And also this is Model 3D combined in motion analysis. We can use a 3D scanner to scan some 3D model data of the target objects, and then import all these models into the TEMA software. We will see the model is moving as like 2D or 3D or 6D. We will have all the coordinates and also, as well as the degrees, the attitudes. It will help when we do the when we do some tests. The target would be hidden by some other objects. So in this case, it will help. And also, we can know the shortest distance between the target and also some reference. Here is car crash test. Like this one, the height, the dummy head is hidden by the airbag, but we will know the actual position of all the details on the dummy head with Model 3D combined in the motion analysis, as well as the 3D analysis and also attitudes. Actually 60 analysis, and it is the distance to be computed here. This is the tear analysis with the movement when the compression is. For the airbag, it used the outline tracker, and here we will know the outline, the circumference, and also the area, and also we can compare to sequences with our color map. For slide test, we can have 60 stick figure here. Yeah. Also for the volume analysis about airbag with different camera views, like 3, 4 or more, and then we will have the volume here. Also, DIC could be applied in this kind of tests. When the tear is compressed, we can have all the deformation or string results. Okay, that's all. Thank you for your time.